Okay, welcome back to Down to Earth Astronomy, and we're continuing our exploration series. As you can see here, I have moved quite a bit. Last time we were in at the lagoon. Um, I've been through several nebulas, and I'm making my way towards the galaxy center. And I thought today I would talk a bit about what kind of objects are actually worth going for, from what I've learned doing my travel, um, and how you find them. So one of your most powerful tools is um, is by going into the view, and you can either select realistic or just a normal map. Um, Show by color, and we select star class. Now we can select and deselect the types of stars we're interested in. Um, the stars with the highest value, normal types of stars, will often be the O, B, and A stars. You can see B stars, none in this area, and they are fairly uncommon. O stars. B stars, a bit more common, and you get quite a few A stars, especially in here at the center where the stars are fairly close. You can get a decent amount of credit just from going around to these stars. Um, but these are by far not the most valuable objects you can find. Um, what the hell? Oh, it's an A-type. Cool. Okay, anyway. But um, what we're looking for is the red stars, the white dwarfs, and the non-sequence stars, especially the non-sequence stars. The non-sequence stars are neutron stars and black holes, and they are very, very valuable to return data with these, and again also very rare. I find neutron stars often to clump together, so you will come across an area with maybe somewhere between 5 or 10 neutron stars in an area, and you can simply jump from star to star, and hopefully we'll find some along the way. So one way to find them is simply just to select this, and then we can begin to just look upwards and downwards. I'm not sure if there's anything in this area, but if we're lucky, yeah, see down here below us, they begin to show up, and if we highlight them, we can see that this is a neutron star. And again, if we go down and select this area, there's a decent chance that there will be more. So in this area, see, and here they come, several more of them down here, more neutron stars. And you can go around, you look for them. I often find that they are off the galaxy's center plane, so you have to move a bit away from the central plane. Um, and again, if we zoom in on this star and we go to a realistic map, we can see they shine with a dim white color compared to some of the, would most likely be an F-type star from the color. But they are way more dim. So if you're good at spotting these types of objects, you can find the dim objects in the realistic map. Now, looking for black holes is a bit more difficult. You can do the same trick because these shows up as black holes. They are non-sequence stars as well. But you can also find them in the realistic map, and they're a bit easier to spot. I found one, and we'll just go ahead and fast forward. I'm heading there at the moment. Here we go. There's a black hole. I am currently 2,000 light years out, so it'll be a couple of hours before I'm there, if I have to stop along the way. So if we go again to the view, we can see this lights up again as a non-sequence star. But if we go to a realistic map, we see it is shown as a black spot. So again, if you're good at spotting these, they really stand out. I mean, the neutron stars can be a bit difficult to spot because they kind of look like, and if I zoomed out, that could look like a neutron star, but it's most likely not. Or it is not. I'm pretty sure it's not. Um, but yeah, so if you're good at spotting these black spots, that's definitely a way to look for them. And I will, of course, be showing you when we get to it, and there's a few things to be careful about. Um, because, yeah. But anyway, I will begin to move towards this, and along the way I will be stopping and showing you what kind of planets I normally go for, what kind of planets I stop to scan, and what type of systems I would just be moving on from. So you'll join me once I find an interesting system. Okay, here we are. I found a system that looks interesting. Again, as we discussed in an earlier video, the ideal planets, of course, you're looking for are the water-based worlds and the Earth-likes. They are rare, especially the Earth-like water worlds. They are rare. You do get it, bump into them from time to time. But what is much more common is these large gas giants, and many of them actually have life on them. And if you do a surface scan of a planet with life, you can get a decent profit once you head home. But you can do a few tricks to spot the planets with life on. The planets with life on tend to be more spotted in the surface color. So if you look at this planet, it's very even compared to, let's say, these two planets, for instance. They have large spots, and this one especially, the white one, has quite a few, so I would expect that this planet might have some life. But we'll start with this one, see how far away it is. It's a decent distance. And we'll get out there and we'll do a quick scan and see if there is anything interesting on this planet. Okay, here we are. We are approaching the planet, and our surface scanner has started and beginning to scan the planet. So let's see what we get and see if we are any lucky. And indeed it was. As you can see here, it says giant water planet here to the right with water-based. So that's just because there's not enough room for the full text. But if we open up the map here, we see that this is a gas giant with water-based life. So this planet actually has life on it. Again, this is a decent profit, I guess, when we get home. And we'll just go ahead and scan the other planet. Generally, I found two types of life. We have water-based, and we have, in the gas giants at least, we have water-based and we have ammonia-based life. I haven't found life on any solid surface planets yet, but pretty sure you can. I would expect at least. And yeah, I'll just go ahead and I'll scan the next planet, and then I will continue towards the black hole. And if I get across any water planets or Earth-likes along the way, I will stop and I'll show it to you guys. Okay, here we are again. I've come along the way and found a system here with a planet here that looks very interesting. I expect this to be a water world. We can see the white dots being the atmosphere, and the blue color indicates this to be a water world. Planet like this might scan it since it's fairly close. I expect this to be a high metal. It's more brownish in the color. Some of these lighter planets, some of them are ammonia-based worlds. I'm not that good at spotting these planets yet. Just to start with, I'm going to scan the star, just because it's one of the large blue stars, so they do give a few credits. Then I'm going to move on to the planet. And again, what you're looking for when you're looking for planets is, again, the large gas planets with the spots on, or the water worlds of the Earth-likes. And that's pretty much what I do when I travel from system to system. I normally find an object that I'm interested in going to. That could be the black hole that we are heading towards at the moment. Oh, 28 is a fair distance, but let's get up there anyway. So normally find an object. I'll show you why we travel there. So for instance, now I'm heading towards the black hole, so I got a route plotted. And as I travel along the way, I just scan the systems. And when I find an interesting planet, I stop, scan the star, and then scan the planet, and then move on until I get to my destination, then select a new target. What I'm probably going to do is I'm going to head over in this area where we have the things around here. We have the black hole. Then I'm going to head towards the center, and then I'm going to head back and just go in a straight line back. Simply because at the moment I've been it's about around a week and a half since I left the main system. And I expect it to be a couple of days before I reach the galaxy center, and then I would guess, with the amount of time I have to play, 2 weeks before I reach occupied space again. So when you're doing this, keep in mind that you will be doing this for some time, and always bear in mind that each time is spent going away from Earth, you have to spend the same time going back. Unless you do what I do, where I zigzag my way towards the center and then just go in a straight line home, then you can get home in a shorter time. But the worst thing that could happen is, of course, your ship being destroyed. I've already done a few repairs. You can see my hull integrity is a bit compromised and down to 93%, nowhere near critical. But the worst that could happen is that you get bored with it. I mean, it's not going to be any fun if you are 20,000 light years from Earth and you suddenly think, okay, this exploration thing is boring. Because then there's pretty much only one thing to do. Either you have to fly your way back if you want the profit from the planet you'd explored, or you have to self-destruct your ship, and you would lose all the exploration data you've collected over the last week or however long time you've spent. So if you're beginning to feel bored with it, I suggest simply turning back and going back towards occupied space. These are at least my suggestions. So keep that in mind when you're out there exploring. So while we admire the great view and the huge amount of stars we see in the night sky, I'll just be flying to this planet, scan it, hopefully we'll get a good result, and then I will continue towards the black hole, and I'll show it to you once I get there. Okay, here we are. We are one jump out of the black hole. At the moment, not a lot to see, but let's go ahead and warm up the frameshift drive. Now, when you jump to some of these massive objects, maybe we're talking black holes and neutron stars, they can be very hard to spot at first. So what I suggest you do is, as soon as you come out of the jump and into super cruise, you immediately stop the ship. Just pull the brakes and stop the ship right where you are. So as you can see here, as soon as I drop out, oi, crap. So that was quite a bit larger than I expected, and as you can see, as soon as we dropped out, we were pulled out of super cruise. This can happen, and there was absolutely nothing you can do. We're gonna have a quick look at the damage. Frameshift drive is pretty much okay. There's minor damage to some of the other systems. The ship was damaged beforehand, so we're pretty good. We're not too overheating, but let's go ahead and make a scan anyway. And here it is. Let's scan this. And as you can see, the stars is so this sphere you see, or circle you're seeing around, is all the stars behind the black hole, and the light being bent around the black hole. That's pretty neat. Normally, when you go to neutron stars, this is not an issue. You can brake before you actually get into the pull-out range. So let's go ahead and open up the system map here. I expect this star to, this black hole to be been discovered before. No, this is actually unexplored. Wow, we're the first people at this black hole ever. Okay, and we got 2 stars around, or 3 stars around it, and a few planets. So for now, we are just gonna try to get into to Super Cruise. See if we can just target one of the stars, like that one. See, just to make sure you find something that is not too close. This should do it. Oh, you can always scan it from this range. That's pretty neat. Okay. So here's what we're gonna do. When we're deploying, oh, here we go. We have to select the group with our heat sinks, because as you can see, we are right now hovering at 32% heat, and I expect as soon as we start up the frameshift drive, this thing is going to overheat quite a bit. So let's get some speed, and we have to retract the hard points before we can
frameshift drive charging.
Can charge. As you can see, pretty quickly align with the escape vector. And we're still heating, so I'm going to launch a heat sink. There's the escape vector. We're throttling up.
4, 3,
just to keep the
2,
heat down.
1.
Go.
Engage.
And this should get us. Yeah, and we're out. Good. I'm just gonna go and get some distance to the black hole. Like that. Break down, and let's have a quick look at it from a distance. And see, there it is. And this is pretty common for what you would expect to see when you are near a black hole. And again, as you can see, they are very difficult to spot, and you can very easily get too close and being pulled out. So that's why I suggest when you are warping or jumping to a black hole or a neutron star, stop your ship immediately, make the scan of the star, and then just get some distance to ensure you do not accidentally fly into it. And here we finally are. After 2 weeks of travel, I make it to Sagittarius A, the black hole at the center of our galaxy. This has been one hell of a trip. One small thing though. When you're in here at the center of the galaxy, you cannot use direct routes. Say, for instance, I wanted to go back, and I would select an object in the right direction, for instance this one. If I click, now I'm not going to do it, but if I click plot route, simply because of the vast amount of stars in here, it's going to take forever for the route to actually be computed. It's simply just too much. It's going to take too long for you to compute the route. So here's what I suggest you do when you need to navigate in here. Either you find some third-party tools. I would prefer online tools, some browser-based tools that can help you plot the routes, and then simply just select the stars from your navigation tab over here. What I did instead when traveling in here, so say that I now want to go back towards Earth, which is this direction, I would simply just move my focus, and I know my jump range is around 30 plus light years, and I would go say 3 jumps. That's 90 light years, so I can go just a little over 90 light years in 3 jumps. So let's go back a bit until we are around. That's way too much. 107, 98, 94 is okay. And this is only going to be 3 jumps. And now we can fairly quickly plot a route. But we have to do it in these small steps. We plot 3, maybe 4. I'm not sure if this can go all the way up to 4. We can just give it a quick try here. So this is just above. Here we go. You see, already with this route, it is struggling. Now it's computing. It is calculating. And there we go. That's the route. And that was only 4 jumps out. So you can do it with 4 jumps, but 3 jumps should still be instantaneous. But we have to do it like this all the way out until, I would say, around 2,000 light years from the center. And then we can begin to use the normal plotting, where we plot maybe 1,000 light years at a time because of the reduced density. But I will be heading back towards known or populated space now. Not gonna take that much of a detour as I did in here, so probably gonna go more on a straight line home, and that's gonna take another couple of weeks. And yeah, you can join me in the next video in this series, where we will be looking at the profit we'll get when we actually get home. So far, I've been out here for, I think I left the station 2 weeks ago. I expect to get home quite a bit faster because I'm not detouring that much, so I should be able to get home in, I would say, within a week and a half maybe. So if you're interested to see how much profit this trip has actually made, subscribe to the channel, give the video a like, and until next time, well, this is Down to Earth Astronomy. Have a good one.